So when we're talking about motion transmission systems, what we're talking about, all right, and there's two key words here in these two different types of systems that we're going to talk about. The first one we're looking at is motion transmission, and that is going to be different from motion transformation. Okay, we need to get those two words separated. They don't mean the same thing. So when we talk about motion, we know that there's three types of motion. Okay, we know that there is translation. What is translation?
When it moves in linear motion?
Translation is linear movement. It can be a horizontal line, it can be a vertical line, it can be a diagonal line. So when we talk about rotation, we're actually talking about a turning motion. And for the most part, sometimes things can rotate in both directions, and sometimes they are unidirectional, which means they can only rotate in one of those directions. Helical, on the other hand, is a combination of both translation and rotation. So helical is a spiral motion. Okay, the arrow for a helical ends up spiraling translationally as it rotates. Sometimes things can move helically in both directions. Sometimes they're unidirectional. Okay, in this case, because I only have one arrow head, it's only going in one direction. Okay? When we talk about motion transmission systems, a system is a machine. Okay, my apple peeler is a machine. It's a system. Do you remember how you had to do subsystems and components? Vaguely? Okay. Well, the system is the machine, and motion transmission systems are machines that take one type of motion. In the case of my apple peeler, it's rotation. I turn the handle, and it rotates the handle. And because there are different components that touch, that mesh in one to the other, to the other, to the other, as soon as it starts rotating at point A, starts rotating, it causes the next thing to rotate, which causes the next thing to rotate, which causes the next thing to rotate, which causes then the last thing to rotate. Everything starts rotating, and it's the same kind of motion. So in the case of my apple peeler, as an example, I start to rotate the gear that is attached to the handle, which then jumps to the next gear because they're touching. Same rotation, which then jumps to the bottom gear, which then jumps to the next one, which then jumps to the thing that the prongs are sitting on. And that turns the apple. The motion is maintained. The type of motion is maintained throughout. It never changes. Okay, whereas motion transformation systems, it changes. It can go from rotation to translation or translation to helical. But in the case of motion transmission, if you start with rotation, you finish with rotation. Doesn't matter how many different things are in this kind of chain reaction. As soon as one starts to rotate or translate, they're all going to do the same thing. If we look at a gear train can only be called a gear train first when the gears are touching. They can't be separated by a chain or a belt or something like that. A bicycle with its chain on the pedals and then to the back wheel, that's another form of motion transmission. Okay, but that's not a gear train because the actual gears are not melding together, they're not touching. So when we've got two or more gears touching one another, okay, interlocking as they turn, any of the odd numbered gears will always move in the same direction as the driver. So in this case, if the driver is moving clockwise, then so will gear number 3 because it's odd. Any of the even numbered gears will move in the opposite direction always as the driver. So if we look at gear number 2 here, And if there were 4, and if there were 6, and 8, and 10, they would all be going counterclockwise or in the opposite direction from the driver gear. So this guy here goes in this direction. Okay, and this is when we have direct transmission. Direct transmission is when the actual gears touch. We know that when we have direct transmission, the gears have to touch. But if you've got a large enough machine, okay, it's not worth your while to put in 10,000 gears so that you can get from point A to point B and make a gear train that big. What is the downside of having a really long gear train? Does anybody know? If you have a gear train that's got 50 different components that are meshing into one another, well, you're more likely to break something. One of those is more apt to break and then screw up the whole gear train, right? What happens when two things rub together? What is created? Friction. What does friction create? What does it cause? Heat. Okay, heat can cause damage to all of these parts. If they heat up too much, they can distort and melt and break. So sometimes direct transmission is not the most efficient way. Case in point, a bicycle. So in this image, we see a direct transmission, which is the lower one. Okay, so we've got direct transmission down here where we've got a driver gear and a driven gear. Okay, and then we've got indirect transmission up top. And indirect transmission occurs whenever a belt or a chain separates two wheels. And I'm referring to a gear here as a wheel because it is circular at the end of the day. Okay? Now, I want you to look at the arrows here in these images and tell me what you see. For what?
The gear circle.
In which one? So if we look at this, notice how they say there's an equal sign here? Well, that is not right. They are not equal to one another. Because when you have indirect motion, okay, when you have indirect transmission, if you want the wheels to turn the same way, put a chain in between them. Because whatever motion, gear number A is going down this way, and it's pushing the chain like so, it's going to push it along like this, and it's going to have to push it in the same direction along the back gear. So we see the same motion. Okay, you want things to go in the same motion. Would a bicycle work if we had this? We'd never go anywhere. We'd be sitting there on our bike trying to pedal, and our pedals wouldn't even move, let alone the wheels. That is not efficient. So we actually overcome that, and we can get larger distances by throwing in chains or belts that still transmit the same kind of motion. They still cause, by turning, let's say my pedals are stuck on this guy right here. There's one pedal and the other pedal's up the top, and I'm pedaling and I'm moving. I'm moving this guy. This guy's rotating. Even though the chain is going along, it's still causing this guy to rotate as well. But it's doing it much more efficiently, and it's lessening the amount of friction. Okay, I only have friction here and friction here, instead of having another wheel here and another wheel here, in order for me to actually get to where I was going. If that was the case, if I had another gear here, I'd have friction, friction, and friction. That's not efficient. Okay, there's less friction in this case, for what we want in an indirectly transmitted motion. Okay? But the rotations is still the same. If you rotate A, it's still going to cause B to rotate. It's just going to change the direction. Now here's the trick. If the wheels are on the same side of the belt, they should be moving in the same direction. But if you were to put a wheel on the outside of the belt or the other side of the chain, it would cause that wheel to move in the opposite direction. You can see a really good image of that by looking at the second image where it says chain and sprocket systems on page 437. If you look at that, you will see that there are 3 actual wheels. There's a wheel down here, there's a wheel up here, and then there's a wheel down here that are all on the inside of this belt or chain, whatever, it doesn't matter. And if we look at the arrows here, we see that everything that's on the inside or the underside of that chain is moving in a clockwise fashion. Okay, moving clockwise, moving clockwise. But then they throw out another little wheel on the outside here, and that wheel ends up moving counterclockwise because it's on the other side of the chain or the belt. So instead of having all the evens moving in one direction and the odds moving in the other direction, like in a gear train, we can accomplish that with chains and sprockets, but we have to have wheels either on the inside of the chain or the band or on the outside of the chain and the band.